So the interesting thing is, what's the relationship between our brain, the quantum universe, anesthesiology, and UFOs? And that's what I'm going to be exploring in a number of films that I'm going to make for you. And I really worry that you, people who are interested in UFOs and UAP, won't be interested, but I think you should be, because UAP are part of a quantum universe. We are in touch with the quantum universe through our brains, so we can detect UAP, and the mystery might be resolved partially. Please consider joining me on this journey as I ask questions humbly and speak to people who know way more than I do about the brain, about quantum mechanics, about consciousness, and about UAP. I think together we might find some interesting things out. So let's start with what I know, and you'll notice that over the next few films, that knowledge hopefully will grow, and I'll share it with you. So you and I are built of atoms. We are solid stuff made of different elements, mainly carbon and oxygen. We are human creatures. And for ages, everybody thought atoms were the fundamental building block of everything. So there was an idea that if you drilled down through a solid, eventually you would get to a single point, a single ball, which they called an atom. I'm talking, this is the atomic theory of the 19th century. And that atom would be solid. It would be a meat ball, a plum pudding was the idea. Maybe made up of subatomic, but it was solid. So if you joined together a lot of these solid atoms, say they were gold, and you made a lattice work of them, you could make a lump of gold by having enough of these individual atoms. Now, we couldn't see them at the time, and we couldn't poke them, and we couldn't explore them, but it made a lot of sense that we were made of solid stuff that coalesces and kind of joins together. But that completely changed with my hero, Ernest Rutherford, with, in fact, gold. So he took a lump of gold and fired these new weird stuff that had been discovered by Marie Curie and others called radioactivity. And it seemed that there were particles or energy traveling through space that hit things and bounce off them. So he wondered how many particles, alpha particles he used, relatively benign things that can be stopped by almost anything, so he wasn't going to die, it wasn't gamma radiation. He wondered how many alpha particles would bounce off a lump of gold or a sheet of gold in this gold foil experiment he did in Cambridge. And what he did was he put a piece of film around the back and round the side and round the front and fired alpha particles at the gold. And to his amazement, he found that 99% of the alpha particles went through solid gold as if it wasn't there. And he came up with this idea that, in fact, atoms aren't meatballs, aren't plum puddings, but are, in fact, energy. In fact, there's no solidity to them at all. And in fact, they were just bonds. And in fact, a single atom started being drawn like, oh, I had one, I don't have one anymore, with a classic center proton surrounded by orbiting electrons. I mean, that was very much Rutherford's idea. And the gap between the electrons and this little thing in the middle that was positively charged, he called a proton, was enormous. And the alpha particles never hit or bounced off the electrons. They were moving around in a fuzz. But occasionally one would hit the proton. And he classically said an alpha particle hitting a proton of gold was the same chance of shooting a fly in a cathedral. And and that's his big kind of catchphrase, the fly in the cathedral. And that totally changed you and me and the world. And we realize that we are not plum puddings. Some of us, we are in fact just bundles of energy bound together with magnetic and electromagnetic attraction. So the universe is just all energy, and in fact, we are very strange. For some reason, we are the coalesced, solid, stable energy that joins together into carbon and oxygen and hydrogen, us beings, or it's wood or metal or air, and it's pretty stable. But in fact, most of the universe is not like that. Most of the universe are distinct elements. Most of it's actually hydrogen and helium, but they're disassociated. They're not bound together. The electron and the positive charged proton are disassociated or ionized. And that means that life out there in the universe is mainly ionized. And that ionized universe is very connected to and has different rules to our universe. And also everything that's made up of atoms is made up of subatomic atoms. And those subatomic atoms, I'm telling this story really badly. All right, just cut. I've got all muddled. So get my physics history right, Simon. So Rutherford discovered the fly in the cathedral, that we were made up of atomic bonds and most of it was empty space. Got that? At the same time, Bohr and Heidelberg and others discovered that there are subatomic particles, and those subatomic particles, which are inside atoms, work in what they called quantum mechanics. And oversimplifying, the quantum mechanics world we thought would work in the same Newtonian way as big stuff. So orbiting planets and stars and gravity and time, but it doesn't. The more people looked at the quantum universe, they realized that it had its own rules. And the big rule about the quantum universe is that it's all connected. Everything is probable. Everything, there is no time, there's probably no gravity, although that's debatable, but certainly everything is possible and everything is connected, however far apart. So that quantum universe is a field which surrounds everything. And ultimately, we, as humans and UFOs and UAP and everything, are in this quantum universe. We are masked from the quantum universe because we live in what we think is this atomic far-field universe of solidity. But inside our atoms, the subatomic particles behave with different rules, and they behave in a quantum state. And we are blissfully unaware most of the time of the quantum state, which doesn't have time, which doesn't have gravity maybe, and is completely connected through billions of miles. It's as if it's all both here, there, and everywhere, and entangled. And that's why I've been talking about quantum communication, because it breaks all the laws. There's no laws of the speed of light. All of those Newtonian or even Einstein laws are thrown out in the quantum world. So, UAP fans, how does this relate to flying saucers and UAP? Well, it ties in with this guy called Hameroff, and he works in an operating theatre. He makes us unconscious doing operations. When somebody wants to saw your leg off, you don't want to be conscious. And the way to make people unconscious is to alter their self-awareness. And there are very strange drugs. Originally, they were recreational, like laughing gas, nitrous oxide, and ether were used in parties as a party drug. And then if you took too much of laughing gas or ether, you actually passed out or became totally unconscious of people manipulating you. Horrible. But it was thought that if somebody was unconscious of what was happening to their body, they might not remember when their leg was sawn off, which is true. Imagine going for a procedure without a anesthetic; it would be horrendous. And but interestingly, the human body is still functioning. For example, he tells a story that in spinal surgery, where you want to check that you don't cut the wrong bit of nerve in a spine, and you're checking that your toes still wiggle, or your fingers still wiggle, they can stimulate the brain of the patient while working on their spine to check whether their toes are still wiggleable or their hands. That means that the larger brain function is still fully functioning. It's just that the person under the anesthetic doesn't remember it. And that has never been really explained. The drugs are weird. They seem to, there's no real explanation of how they affect the brain. They also affect animals and they also affect plants. So what's going on there? And he proposes that there's a mechanism called microtubules, and these drugs, these anesthetic drugs, bind to it and block signals. And interestingly, the microtubules are small enough to interact in a quantum world. Aha! So there's a connection between the weird quantum UAP universe and anesthesia. So let's go down that road today and learn about microtubules just to start off. And then where I'm going with this, and hopefully you are on board for this journey, is, are UAP a subatomic quantum phenomenon? And are we inherently born with a mechanism to perceive them a bit? And some people perceive them a lot. A lot of the experiencers who've had UAP, UFO experiences also tend to be aware of ghosts and other things that appear in their room, hitchhiker phenomenon, and it seems that they become sensitized to a quantum realm, which is out there. It definitely is out there right now, but we are mainly blissfully aware of it. And then, of course, fascinating, I've been investigating the CIA's use of remote viewing, and the way that remote viewing apparently works is by tapping into this timeless nature of the quantum universe. And if something amazing happens in your future, you can perceive it in the present, because the future and the present in the quantum world are connected. And all you need is the ability to tune into the quantum timeline, which doesn't have past, present and future. It's omnipresent, that you can actually predict something that's going to happen. And then you and I all have that gut feeling and premonitions and worried about things that might happen, and we're quite good at predicting the future. Maybe we're using this brain ability, these possibly microtubules, to contact the quantum state. And then we have people like Jake Barber, who talks about summoning UAP, using people who are good at being in touch with their consciousness. And I think it's all connected. So, avid, keen viewers, and thank you very much, the people who have been supporting me over this outrageous claim that the Tic Tac is human. I mean, I really upset the world over that. I've really lost a number of really good friends who've dumped me. I mean, to be honest, I said that about 2 years ago when Jeremy Reese and Joshua Bertrand told me about vacuum drones. And I think what they researched, not me, but shared with me, and I did a video on this humble channel, was the precursor of what Ross Coulthard is kind of obviously got some inside information that these machines, these drones, are being now mass produced by Lockheed Martin. But I think Jeremy and Joshua found the mechanism of how they work, and it kind of peed me off that Ross and people are going, it's Lockheed Martin, without actually crediting and looking at how they work and what they could be. It's a bit like the Calvin case where David Clarke's more interested in the photographer and I'm more interested in what the craft is. It's not good enough just to say it's Lockheed Martin made the Tic Tac. You want to know, well, how does it work? Does it all add up? And it doesn't, by the way. It's kind of maybe adds up. The place it was tested, yeah. But some of the ways that it obviously moved, that you've pointed out very stringently to me, that you feel that I've ignored, doesn't correlate to normal things in normal gravity. It tends to, I don't like this phrase, but it breaks the laws of physics. There's some propulsion technique which is going on. But I still think it probably was a man-made device. How exactly it works, I don't know. So join me on this journey to see if we can get a different tack, a different angle on UAP by exploring consciousness, not in a woo-woo way, but in a very practical way. And I'm starting on this journey knowing nothing. I've seen a few YouTube videos. I obviously am a big fan of Tim Ventura and all his guests, so I will point you in that direction. So today, as an introduction, here's a clip from Tim Ventura's channel with this anesthesiologist in America who's talking about anesthetics. And hopefully it will grab your interest. He talks very well. And there's a link in the description to Tim's channel and the full interview if you want to see more of it. So, are you interested in this? Do you think there's a connection between the quantum world and UAP? And would you watch my humble videos on it? Or are you just going to go, we're not interested? It's a challenge for me because I'm interested in all science. And the number of times I've done films about non-UAP science, nobody watches them. I've done like the history of the string vest, or who invented Velcro. It's only when I have the keyword, the metadata UFO in the title, do you watch. So I'm doing this today as an introduction to tell you that possibly the connection between consciousness, the way our brain works, this subatomic world, and UAP are very connected. And I think we might unlock some of their mysteries and also help some of you who are experiencers understand what's going on. If you're interested, tell YouTube by pressing like now, subscribe, and join me on this journey, because the truth needs to be out there.
People have been looking for the molecular target of anesthesia. In the 19th century, gases were discovered which, when inhaled at low concentrations, caused euphoria, giddiness, and they were used for social interactions, for entertainment. Ether frolics, sniffing diethyl ether, nitrous oxide, laughing gas. And so they partied with them. And then, but if they took a little bit more, if they kept on going, they became unconscious. And people eventually realized this could be useful for anesthesia. And in 1846, the first public demonstration of anesthesia was done at Mass General Hospital. And ever since, it's been a staple of our lives. Imagine what life would be like without anesthesia. If we had burst appendix or broken arm or something, we'd be facing agony. So it's a really good thing. In China, the gases are all different, but they do the same thing. This is really bizarre. They're all selective, affecting consciousness. But if you look at their molecular structures, they're ethers, they're elemental xenon, they're halogenated hydrocarbons. But they have one common feature, and that is they have at least part of their molecule that is nonpolar, that has no charges. So it doesn't make the sort of electrical or magnetic charges that most drugs do, which are soluble in water. So oil and water don't mix. That's a basic solubility. So the body actually has many solubility compartments, 20 or so. But the main thing is oil and water. So oil is like lipid, nonpolar, aromatic rings, the basis for organic chemistry. benzene, indole rings, which are found in the psychedelic molecules. And they don't like water, so they kick water out when it's around them, and they go to get away from water. And that's in what are commonly known as fat stores, but also include regions within proteins. And ultimately, you have to explain the activity on proteins to explain loss of consciousness with anesthesia. Anyway, these guys at the turn of the 20th century showed that the potency of all these different anesthetics, despite their chemical differences, was proportional to their solubility in one particular solubility compartment, which was olive oil. So they studied all these solvents from water to acetone to this to that, and they measured their the solubility of all these different gases, and they also knew the potency of the gases from their action on putting animals to sleep. So they'd expose rats or mice, like we heard in the Wellesley study, and see at what concentration they would fall over, or at what concentration they would move or not move when they clamped their tail. And that concentration became known as the well, it's the effective dose, really, in pharmacology, but it became known as because they were gases, the median alveolar concentration, the concentration in the alveoli of the lungs, in equilibrium with what was in the breathing circuit in the machine and the vaporizer. So at equilibrium, the concentration of the circuit was equal to the concentration at the site of action in the brain, even though we didn't know what it was, because it's all partial pressure. So what was the site of action in the brain, which had to be like olive oil, where anesthetics went and stopped consciousness because they're binding to everything all over the place, in fat stores by these very weak quantum effects. So they don't form covalent bonds or chemical bonds. So they're going all over to fat stores and binding to everything by these weak quantum actions. Anything that's anything like olive oil, which is lipid-like or fat. So then and because they all acted the same, and because each anesthetic had the same concentration, the MAC, to put a horse, an insect, a worm, you or I to sleep, all the same. They were equipotent. So which tells me that consciousness is really the same in all animals and maybe even plants, because they respond to anesthesia too, despite our differences. But consciousness may be something common. Anyway, then the question became where did anesthetics act to have this effect? And it bound to everything. So among this big reservoir of possibilities, which particular target? And eventually it had to be a protein. We knew that from other reasons. And it was assumed to be membrane proteins, receptors, ion channels, because they mediate the excitability of membranes and so forth. And they bind neurotransmitters. So when it was determined that it was protein site of anesthetic action in 1984 from Franks and Lieb in the UK, the search began for which membrane protein and mediated. Was it the sodium ion channel? Was it calcium channel? Was it receptors for serotonin, for acetylcholine, for GABA, the inhibitory? And the GABA receptor, which is an inhibitory receptor and a chloride channel opener, is inhibitory. So when it opens, chloride goes in, and that inhibits the activity of that neuron. And so everybody assumed, well, they must agonize, they must potentiate the inhibition. But the problem is they needed one target that all anesthetics acted at, and not all anesthetics bind to GABA. And other studies have shown that GABA can be active in unconscious states. So it's not GABA. And in 2008, all the leaders in the field concluded that the 25 years of study of which membrane protein was futile, and they gave up. They quite literally said, we need a new paradigm. It's not membrane proteins. It's not one membrane protein. It's not any group of membrane proteins. It must be something else. So I thought this was a great day when I read that, and I wrote to everybody involved. I said, well, yeah, it's microtubules, because I've been thinking that anesthesia acts on microtubules for a long time, and there's actually evidence. Back then, it was being ignored because everybody has this orientation towards the membrane protein, towards neurons being empty and just their membranes firing and being active, and that's how signals are processed and they lead to consciousness, ignoring the interiors of what might be going on there. And I call this view cartoon neurons, because you're only looking at the outer shell and they're basically empty inside, and they're not conscious, in my opinion anyway. But cartoon neurons are actually the party line in neuroscience and the neuroscience of consciousness and philosophy, and plays up to AI very well, because AI neurons are no different than cartoon neurons. So this has caused leading figures like Chalmers and others to say that AI is going to be conscious inevitably, because, as he says incorrectly, silicon is no different than biology. Well, that's completely wrong, but nonetheless, that's their argument for cartoon neurons. Anyway, if it's not membrane proteins that mediate consciousness and anesthesia, what is it? So back in 1846, actually, the same year that the first human anesthetic was performed, Claude Bernard, a famous scientist, was studying amoeba. Amoeba crawl along by oozing their microtubules, and then the actin flows, and they ooze along, and he exposed them to the anesthetic gas chloroform, where they just stopped in their tracks. And then when he blew off the chloroform, replaced it back with air or oxygen, they resumed their motion. So that was interesting. And chloroform's a good anesthetic, and presumably any other anesthetic would do that. And in fact, recently, in the last 10 years, people have studied this same amoeba, the same slime mold organism that oozes its tentacles in different directions. And this guy, Adam Adamatsky, and his colleagues and many others constructed these wells with food and aversive stimuli in all the different radial spokes, kind of like the different corners of the well, so they can have attractions or aversions. And they designed a study that was basically the traveling salesman problem. You know, in computer science, there's this problem of an NP-complete problem, where the salesman has to go to all these different cities, which is the most efficient way order to go. And it's actually pretty sophisticated problem. It's been solved fairly easily in recent years. But the point is that Adamatsky designed a traveling salesman problem for an amoeba, which solved it. It's oozing its microtubule-based pseudopods in different directions, solve the traveling salesman problem. So it doesn't say that that's conscious, but that's certainly intelligent, or at least problem solving. And that's what was being blocked by anesthesia. So then in 1968, these guys, Allison and Nunn, John Nunn, who actually I met, who was a British anesthesiologist and friend of my first chairman, Bernal Brown, did a study on actinospherium, which is a tiny urchin with spikes coming out of it that are actually made of microtubules. And if you cut the spikes, you see a double helical array of microtubules longitudinally. When they exposed these things to halothane, these axonemes depolymerized. They were gone. They just collapsed. And they published in Lancet, the preeminent British medical journal, that anesthesia was caused by microtubule, if not disassembly, because they used higher than what was required for loss of consciousness, some effects on microtubules. And in fact, that paper is one of the reasons I went into anesthesia, because I was interested in microtubules, interested in consciousness. And Bernal, my future chairman, said, "Hey, look at this. If you figure out anesthesia, that'll tell you what consciousness is." I said, "Yeah, that's right." And he said, "Plus it's a lot of fun and good money." And I did it. And that was 50 years ago. So I had a wonderful career in anesthesia. Now I'm retired and still studying consciousness and still looking at anesthesia effects.